In this video, I'm going to show you the process of creating a Makefile, and I'm also going to replicate some common student mistakes. So first, in order to create the Makefile, what we need to do is we're going to do touch Makefile, and then we're going to vim into Makefile. So in the tutorial, I show you that pound is a comment, and you should put your name to indicate your ownership. So if you're working in pairs, you can have your partner. So I'm going to say that my partner here is Grace Hopper. And I'm going to put email. I'm going to put at nd.edu. We'll say that ghopper at nd.edu. And then date created. So the day of the first lab assignment is 31 August 2021. I'm going to add in a space here, and then I'm going to say this contains the Makefile commands for lab 01. And then I press enter. If I press backspace, it gets rid of the comments and I can start adding in specific variables. The first one I'm going to do is I'm going to do the instance of a compiler variable. PP here is going to be used to replace with GCC anywhere it goes. Then I can do CFLAGS. And the reason we want to do this is if we have several executables in the file, instead of having to go through and replace every instance with GCC, I can just replace it here and then it will populate everything else for me. In the write-up for lab 1, notice how I have these specific flags. And I go into a lot of detail about what the flags actually are up here. Yeah, so when you read through this before, you know what they are, but I'm going to state them again. So here we are. The first one I'm going to create is O2. So if I come down here, dash uppercase O, 2, not the number 0, not lowercase o. So that means we optimize when we compile from the C file down to the machine binary. The next one is going to be -G, and that means that we can use the GDB troubleshooter to be able to determine whether or not our code actually works. All warnings, W all, these are the ones we've covered in class already, W extra and W conversion. The next compiler flag we're going to implement is W shadow. This specifically makes sure that we do not create a scenario in which we have two variables with the same name and same scope. The next compiler flag is standard equals C11. This means that we're going to use the compiler rules for the 2011 C standard. Next, we're going to use W error. As we've discussed in lecture, we're going to force all compiler warnings to be as errors. So let me go back here and go W error. The next one is lowercase l m, and that stands for link math. And so here is a summary of everything. And so I'm promoting good coding commenting practice on the page. So I'm going to say C compiler, and GCC stands for GNU C compiler. We'll say production quality compiler flags for C programming in CSE 20312. And so now we're going to press escape, hold shift, :W. So we're not going to quit yet, sorry. Like so. And now I'm going to set up the first command, which is we're going to create line1.o. It's an object file when we take code.c code and change it to the object file, which can be interpreted by the machine. So we're going to say line01 object file. And the way we do this is we say the command is line01.o colon. The next thing we're going to say is the dependency. The dependent file, the file that this object file is dependent upon, is line01.c. The next step is extremely important. This is actually the primary reason why I want to do this on video. When you want to do the actual compilation, there's one of two ways you can do it. You press enter, and this is the important part, you press tab. You tab it over. If you don't tab it over, if you have spaces, it will not work. And I'm going to replicate that error and show you how to fix it. In order to call a variable in a compiler, you do $. This fills in GCC, and then we do CFLAGS. And that puts in all the compiler flags for us. So if we ever want to change them, or we want to update the compiler, it becomes much simpler to perform. To translate a .c file into an object file, you do -c, and then we state line01.c. This means take line01.c and convert it into an object file. At this stage, now I'm going to do escape shift : right quit, and then I'm going to run the command make line01.o, and that's going to create an object file. So let me move this, and I do ls, we're going to see that line01.o has been created. Now we're eventually going to create a command called make clean. I'm going to show you right now why. If we do ls-l and we get the details, we see that the .o file is significantly larger than all the other files. And when we create the executable, that one's going to be large as well. So we want to clean out object files and clean out the executables so we can respect the space of the machine. To do this, let's go back into Vim Makefile, and then we're going to create an executable. To create the executable, I'm going to say the command is line01, and we are dependent upon object files. So how do we actually do this? Because in a data structures course, what we're going to see is we're going to have several object files be combined into one executable. So for now, I'm going to put TBD. We're going to come back and change that. And I'm going to create a variable called line_01 objs for objects. And it's a variable, so I do : equals. And for this one, all I'm going to do is line01.o. As we get into bigger projects, having more object files, it becomes much easier to simply use that variable, the $, so that way we can combine everything into one. I'm going to show you what I mean right now. In order to execute this, I need line01 objects, right? We're going to let me scroll down here. I'm going to press enter a few times so it's more visible. You have to press enter and tab, and then we're going to do the same thing with our flags. You do -o, take these object files and create an executable. Now, where students can get confused is it's a little more backwards than you might think. But the whole idea is you say, this is what I want the executable name to be. And then you say which object files, right? So now we take these object files and make the executable line01. Now I'm going to say right quit. And let's test. We're going to make line01. And we see that it took this object file line01.o and created an executable line01. If I press ls, we see in green here, line01, we now have an executable, and this file is the void pointer version of hello world. The next thing I'm going to do is I'm going to put in some deliberate mistakes to show some issues that come up. So let me vim back into the Makefile. And the first and most common error that I see is if they don't tab. So if there's no tab, right quit. What we're going to do is we are going to get a Maybe remove line01.o and line01. I'm going to show you how to do that in a Makefile in a moment. But what I'm going to do is I'm going to make line01.o, and we're going to see that's not going to work. And the reason why is because we have this missing separator. Oh, what's that? That's the separator between the dependencies and how we're actually going to compile the code. So there's two ways to do a separator, and I show them both in the write-up. So I'm going to go back to the write-up and show you what I mean. Here we are. So one way we can do it is with a tab after enter or with a semicolon. So the first way to do it, to fix this, is enter and tab, and we're going to write quit, and then we can make line 01. Now I'm going to remove line 01.o, and I'm going to show you the second way to do a separator. The second way to do the separator is with a semicolon. And you can tell if the separator has worked because the -C, there's going to likely be a different color in Vim when you see it like that. That means it's worked. So I can do the same thing and we can compile. I'm going to make line 01.o and we see that it works. The next thing I want to show you is sometimes it will look like this. 1, 2, 3, 4. And maybe they're even lined up. I quit. And it says missing separator. Say, did you mean tab instead of 8 spaces? Turns out you do. So you go here, you go to the line, and you can tell here at the bottom, 15,9. We're at line 15. So like, oh, yep. Did you mean tab? And there it works. If it doesn't work, you see how it's actually a different color? It's white there. And if I tab it, it changes. That's its way of letting me know that it worked. So I'm going to run it again. And then I'm going to make line 01, and we do the second one. Now I'm going to show you how to do make clean. Because we do ls-l and we see line 01 is huge and line 01.o is huge. So what I want to do is we're going to go back into the Makefile and we are going to run a executable. So let me actually promote coding. So line 01 objects and line 01 executables. Executable. So in the rest of the lab, you're going to do line 2 and line 3. And I'm going to show you a way you can use a file transfer protocol to simply copy and paste. But for first I'm going to do is clean. The command is clean, so you do a colon afterwards. There's no dependency. We don't rely on any files. What we're going to do next, so let me repeat this step. Enter, tab, and now we're going to say we want to remove files. RM space -RF. This stands for remove, and then recursively force. The next thing we want to do is use that keyword character and then .o. Now we're going to delete every object file. Now, before you do anything else, this is important. This is a very common new programmer mistake. They'll accidentally put a space and .o. What this means is delete every file in this directory and subdirectory. That's not good. Make sure that you don't have a space between those two. And then we're going to say the executable, just line 01. And now I'm going to make clean. And we do ls, and we see that our files have been removed. Now here's the other thing. Setting it up this way really helps you. So I do make line 01. Now it has to go through all the object files and say, hey, I need that object file, and it's going to call it. So you see that it actually runs both. First, it generates the object file. And then from the object file, it generates the executable. And if I press ls, we see that we have our executable and our object file. And then I do /line01, prints hello world, make clean, and it's gone. The next thing we're going to do is now I'm going to go into the folder where I have this. So the folder where I am presenting from, I'll just do present working directory just to check. I'm going to go into the solutions folder here, and I am going to open with default text editor. And after a moment, it's actually going to open it up here. So here I have line 01, right? If I create new and I copy this, I can replicate everything. So now I can say Control H, search, replace. So I want to replace every instance of 01 with 02. Find next, and there we go. We have them all replaced, and now I can copy and paste into here. And then I can do the same thing, search, replace, find all instances of 02 and replace them with 03. Find next, and now we have all of these. I can press enter a couple of times, like so. So the next thing we're going to do is we're going to add line 02 and line 03 to our make clean. You see this little star here? That means we need to save and update. So when I save, we're going to see the make file has been modified. Do you want to replace the remote file? So now we're updating the file on the Notre Dame student machine. Yes, we do. And we see that's updated. If I do vim makefile, we see that line 02 and line 03 are there. Now, the other thing that I have made a note of is making sure that this -C and -O have different colors. If they have different colors, that means all the tabbing worked, right? And so I am going to get out of this file. I'm going to clear, and I'm going to make line 01, and it compiles, and do line 01, hello world. We're going to make line 02, and I can do /line 02, hello world. I can do make line 03, /line 03. And so those are three different versions of hello world at different levels of abstraction. The thing is, wouldn't it be nice if I didn't have to run all three of those make commands when I'm demoing to the TAs? So the way we can do that is to apply the same type of principle. We have lots of big executables and big object files. So if I run make clean, we see that we have significantly cut down on the memory in our folder. So the last thing we're going to do is we are going to run a command that runs all the executables that we want to do at once. And typically you'll put it right before make clean. Scroll down here and we're going to write make all. And the way this works is all, and it has to generate the dependencies first. So line 01, line 02, line 03. And then I enter and tab. And now I'm going to say, I want to run the executable line 01, enter tab, line 02, enter tab /line 03. This will generate the executables and then run the executables. So I'm going to enter, hold shift, tap, :WQ exclamation point. And now I'm going to run make clean to make sure there are no object files or executables. And then I'm going to run make all. So the first thing it does is it generates the object file line 1.0 and then generates the executable line 01. Then it's going to have line 02.0 and then line 02, line 03.0, line 03. Then it runs the executable for each one. So for the rest of the lab, what you're going to do is you're going to develop a haiku. In line 01, you're going to use void pointers only. You're going to use char star pointers in line 02. And in line 03, you're going to write a classic fprintf with a string, just like we have presented in class.